Hi everyone. So today in this lecture we will learn about finding zeros of a polynomial. So in this chapter, which will be helpful for class 9th, class 10th, high school standards for US European countries. So this topic is quite beneficial also for the higher studies. So polynomials you will have to learn everywhere wherever you go. So firstly in this lecture what I'm trying to cover is, firstly, I will, with one example, try to show you what is the zero of a polynomial, how we can find it with an example, and then we will go about doing some sample questions, and so that you get the basic clarity about that. Then I will show you one simulation powered by Colorado University, and this is the simulation for the physics, but in physics, the same type of polynomial questions will arrive in your class. So you will understand why the polynomials are important in your real life. So you will able to see how math is collaborating with physics to explain you the nature of motion. And then we will do this sample type of a question, which is based upon significance of zeros of a polynomial. So let's begin. Let's firstly do this question, which is so suppose we have equation, say a polynomial equation, which we can see on your screen. Say we are saying a polynomial equation px equals to x square plus 5x plus 6. Now say, for example, I put x equals to 1 into the equation. Okay. So let's put everywhere x equals to 1. Okay. Wherever there is x, just put x equals to 1. So p of polynomial at x equals to 1 will be 1 square plus 5 into 1, 5 plus 6. One thing, just seeing this, can you tell me the polynomial at x equals to 1, is it a 0 or non-zero value? Yes, you are right. It's a non-zero value. We get 12 as the answer. 6 plus 5, 11, and then 1 square is 1. So 12. So it's a non-zero. So polynomial 0 means that if a value of x is put into this equation, or such value should be put into this equation, such that the polynomial should give us 0, means overall calculation, subtraction, addition should give us 0. So let's do this. Now see, we need such values of x where polynomial of x results into 0. So you must have learned this, that you can do by factorization of that. Someone who doesn't know that. So by random, suppose I'm saying value of x equals to minus 2. So let's try this. So when we put x equals to minus 2 in the equation, we get minus 2 square plus 5 minus 2, 5 into minus 2 plus 6, which is then again minus 2 into minus 2, minus minus gone, so that will be 2 into 2, that is plus 4, plus 5 minus 5 into minus 2 is how much? Minus 10. And this is, now you see, 6 plus 4 is 10, and then 10, that is resulting into 0. Now I can say that this value x equals to minus 2 makes this polynomial equation resulting into what? 0, means x equals to minus 2 is 0 of a polynomial. Simple. Got it or not? So 0 of a polynomial are those values of x which results polynomial into 0. If they are not the zeros of a polynomial. As simple as it is. Okay, so let's do one more example from the exercise which I have shown you. Now say this question. What it is saying that you have a polynomial 5x minus 4x square plus 3. Okay, and it is saying find the value at x equals to 0, x equals to minus 1, x equals to 2. It is only saying just find the value. We will do two things. We will find the values and we will make sure to answer that whether it is a 0 of a polynomial or not. So let's do that. So our equation was px, say polynomial of x equals to 5x minus 4x square plus 3. Okay, so minus 4x square plus 3. Okay, so at x equals to 0. So now at x equals to 0 it is saying, so let's put it in the equation everywhere. So p of 0 will be 5 into 0 minus 4 into 0 plus 3. What it is resulting? 5 into 0 is 0, 4 into 0 is 0, plus 3 means equals to 3. Now tell me whether this polynomial is resulting 0 at x equals to 0. No. So x equals to 0 is not 0 of a polynomial. Don't get confused by this. Just remember 0 means polynomial must result into 0, but it is resulting 3 when I'm putting x equals to 0 in the equation. So it's not a 0 of a polynomial. Let's put another value. It is saying put x equals to minus 1. So let's put x equals to minus 1 in this. Let me do this. Now x equals to minus 1. Now this will be p of minus 1. 5 into minus 1 is minus 5. Minus 4 minus 1 ka square plus 3. Now this will result into minus 5 minus 4 because minus 1 into minus 1 is 1 plus 3. That will result into minus 9 plus 3, that is minus 6. Now again ask one question. X equals to minus 1, when I am putting this value into polynomial, does polynomial at x equals to minus 1 resulting into 0 value? No. So it's not a 0 of a polynomial. That's it. Okay, so let's do one more thing. Let me clear this out. Now again there is one more value, x equals to 2. So let's put that value also. So now equation was px equals to 5x minus 4x square plus 3. Quickly do it. X equals to 2. You can do it with me also. Okay, so keep on doing with me. So that will be 5 into 2 minus 4 into 2 ka square plus of 3. That will be 10 minus 4, 2 2s are 4 plus 3. That will be 10 plus 3 minus 4, 4s are 16. Again, that is a 3, 16 equals to minus 3. So again, x equals to 2 is minus 3. So none of the values are resulting in this equation, question number 1. None of the values are resulting into 0. So at x equals to 0, at x equals to minus 1, or at x equals to 2, the polynomial 0 doesn't arrive. So none of the values are 0 of the polynomial. Okay, so as I shown you in the previous question where x equals to minus 2 was resulting the polynomial to 0, so then you can say that this is the 0 of a polynomial. Now similar type of questions are there in the second part. You can try it by pausing this video. Say you can put this is the polynomial in y. So don't worry about the variables. I have seen the students who gets worried about key. Sir, it's written y, is it in t? What does it matter? Whatever alphabet you change, you have to do one thing. P of 0 means put y equals to 0, 0, 0, 0, and then 1, calculate it. They are just asking you to find the value. I am saying you go one step ahead, find the value and see whether the value is getting 0 or not. If it is getting 0, it's a 0 for polynomial. Means you are solving two questions by single-handed. Again, you can do it p equals to 1, put y equals to 1, p equals to p0, put x equals to 0. So similarly, just equations may be written in a different forms, but all that matters is that they means the variables may change, their factorization may change, but they all will result in the same thing. Now, if you see there, this fourth one, px equals to x minus 1 and x plus 1. Now let's do one thing. Let's try this second question, fourth part. It's interesting observation is there. That's why I'm picking up this question so that you can understand what it means. So let me clear this out. Now, the second question, fourth part was px equals to x minus 1, x plus 1. So from the previous videos or from class 8, you can see this equation is in form of factors. This is a factor 1, this is a factor 2. If I multiply them, x x x this one, this one, this one, and this one, then that will be equation of the form, say x square one term, x one term, and 2 or minus 2 one term. So that is the overall polynomial equation, but this is a factor form of polynomial equation. Which form? Factored form. Now, very simple observation is this. If I put x equals to say 1 in the above equation, then p of 1 will be 1 minus 1 into 1 plus 2. Now this will be 0. 0 into any term, that is 3, will be 0. So tell me, this x equals to 1 is what? Think for a second. Pause the video. This x equals to 1 is making this polynomial px resulting a value 0. Means x equals to 1 is 0 or a factor of polynomial. So in previous classes you must have read about this. So the factored value of x makes the polynomial turning into the 0. That's why I picked this question. So even if you have to find the 0 for polynomial, you can do it by a factorization method. Find the factor, you will get the values of x, and those values of x are polynomials of x. So one more observation is there, says this x equals to x plus 2 equals to 0, x equals to minus 2. Put this x equals to minus 2 into the equation. See, again this x plus 2 will become 0 now at x equals to minus 2. Then this is also 0 of a polynomial. So there are two zeros of this polynomial. One is x equals to minus 2, another is x equals to minus 1. So if you see, these factorization terms are giving us plus 1 direct hint about what are the zeros of a polynomial. Okay, so factored value of x's are nothing but the zeros of polynomial. I hope you have understood. That's why I picked this question. You may try other examples or the questions in that. You can factor that, say for example question number 2, you can pick part 1. You can factor this y square minus y plus 1. You can do it like 2 ones are 2, so 2y minus 1y, and then you will get those factored term in this form, right? And then you can simply solve those to get the 0 of a polynomial. I hope I am making sense. If not, please drop a comment in the comment box. Now let's move on to what is the significance of a zero for polynomial. So for this, let me show you a lady. You can choose a boy. So you must be seeing this link. This is the Colorado simulation link. You can follow this link or type in Google Colorado edu, and you can go to this link. I will drop this link into the description of this video. So what is happening is, let me show you. So you are seeing this lady is traveling from here to there. Now she's going up, and then this is the bottom section of the lady, right? So the motion followed by a lady could be represented in the form of a polynomial. Now this is what I'm trying to say. If someone is, say, walking, and their behavior of walking needs to be represented by a mathematical equation, then it could be in a form of a, say, this lady which you have seen previously in the video is going oscillating from here to there. So she's making this kind of a parabola. Now this type of a motion, and she's doing that, could be represented in a form of a polynomial, say a value having 2t square plus 5t plus 1, or some value. I'm not going about exact value. Then what is a zero? Now what is a zero? The question will be, okay sir, you are saying that any such type of equations can be a motion of a person or a object or a car could be represented in a form of a parabolic equation. This is called parabolic equation. Then what is a zero? So zero is nothing but the moment it touches that, the moment the lady is at the bottom surface and touching this x-axis, because this is a x and this is a polynomial px, the values which you are getting, at those values where px is getting 0, at this point when she's at the minimum. Now this lady is at the minimum. I hope you are seeing my screen, right? So at this point, the value of px on y-axis is what? Now at this point she's getting px value is 0. Say suppose I'm getting 0 at x equals to minus 2, x equals to plus 2, and suppose the lady is doing this type of motion, then this x equals to plus 2 in this form will be 0 of a polynomial. Means very simple thing. The values of x where the lady is coming at the zeros are decreasing the value of a function to be at 0. Such values are 0 for polynomial. So in the real world, what we do now, these types of intersection, let me redraw it. I hope I'm making sense. So suppose you get motion of a car, you will read in a physics in higher classes also that such type of equation you are getting. Now these 2 points where the value of a function is getting 0, then these x's where it is getting 0, x, say x plus 2, and then say this is x equals to 5, are nothing but, just a random example, are zeros. So zeros tell us na ki where the crossing are, where the person is crossing. Like say this lady, she's crossing from down the hill to up the hill at this point. At this point she's doing that, right? Now this is nothing but a what? This red point we are seeing now, this red point which I have just paused. Now see, let me pause this. This is nothing but a 0. After this point, what the lady will be doing a motion? She will go upwards. Now before that, this is the point of a 0. Before that, she was going down the hill and then up the hill. Are you getting it? This is a point of interest. This is the point where the motion behavior changes. That's why we need to read about the polynomials, and that's the biggest significance of a polynomial. I hope I'm making sense. If not, then you will get more clarity when I will be putting the videos of motion in physics classes. I hope you will like that. After this, there are second type of a question which you can see on your screen. Verify whether The following are the zero for polynomial. It's the same. Just put the value of x equals to. Let me do one example for you. Say third part 1. So 3x plus 1 at x equals to minus 1 by 3. Let me draw this. Okay. So they are saying we are giving you px equals to 3x plus 1. What is the value at x equals to minus 1 by 3? So kya, whether it is 0 or not, 0 for polynomial or not. So I taught you, put the value. 3 3 gone, minus 1 plus 1 equals to 0. Means in a graphical terms, this is nothing but equation of straight line. So say suppose this is a straight line you are getting. So at this point, let me now, this is the point where we are getting, right. So somewhere at x equals to minus 1 by 3, the function is getting 0. See, 0. This is the significance of that. Say someone is doing a motion like that. So when it is doing a crossing like that, so you can think about it. Similarly, you can do other examples. These are very pretty straightforward and simple one. If the value of function is getting 0, means it's a 0 for polynomial. If not, then it's not. Say this fifth part, you can just by seeing it tell that it is a 0 for polynomial. At x equals to 0, px is 0, 0 for polynomial. I hope I am making sense. If you like this video, I hope you must have. You can try these simulations and you can reach out to me in the comment box. Thank you so much for listening to me. Bye bye.